This is 3.1 Lesson 2, Investigating the Rates of Change for Different Functions. So our directions are to graph each equation using a table of values and tell whether it's linear or nonlinear. So our first example is we have y equals 2x minus 3, and so we need to pick 3 different x values. We can pick -1, 0, and 1. Now to show our work, we need to go ahead and plug them into our equation. So we'll have 2 times -1 minus 3. So we know 2 times -1 is -2 minus 3 is -5. When we plug in 0, we have 2 times 0 minus 3, which will give us -3. And then we plug in our 1. We have 2 times 1 minus 3, which will give us -1. Now we can go ahead and graph this. So we have the point. We go left 1, down 5. We move left and right 0, down 3. And then we move right 1, down 1. And we can go ahead and connect our dots. Now in order to check this, we're going to check using our rate of change, which is what we learned yesterday. So if you don't recall from yesterday, we find rate of change by taking our change in y over our change in x. Now what we're going to do is we're going to take our points and we're going to start off with just 2 points. So I will use -1 and -5 and 0 and -3. So for our rate of change, the first thing we want to find is our change in y. So we see that our y's are increasing by 2. And then our x's are increasing by 1. So for these 2 points, our rate of change is going to equal our change in y, which is 2, over our change in x, which is 1. So this gives us a rate of change of 2. So now we can do the same thing with the next 2 points. We have the point 0, -3, and 1, -1. So again, we need to find our change in y, which is adding 2, and our change in x is adding 1. So then our rate of change for these 2 points, we'll do our change in y, which is 2, over our change in x, which is 1, and it gives us a rate of change of 2. Now, like we said yesterday, if we have the same rate of change, it is linear. We can also have several different ways of being able to tell. First of all, from our graph, we see that it is a line, which makes it linear. The other thing that makes it linear is when we have a regular x and a regular y, it is automatically going to be linear. So now let's look at example 2. We have the equation y equals x squared minus 3. So again, we need to pick out 3 x values. So we can use -1, 0, and 1. And we're going to plug these in. So remember, anytime we square a negative, we want to make sure we put it in parentheses. So we have -1 squared minus 3. We know -1 squared is +1 minus 3 gives us -2. Then we can plug in 0 squared minus 3, and that will give us -3. And then we plug in 1, we have 1 squared minus 3 will give us -2. Now just to give us a few extra points here, I also want us to try x values of 2 and -2. So if I plug in 2, we have 2 squared minus 3. So 2 squared is 4 minus 3 gives us a 1. And if I plug in -2, make sure we put it in parentheses. So we have negative 2 squared is 4 minus 3 is also 1. So let's go ahead and graph these. We have negative 1, negative 2. We have 0, negative 3, 1, negative 2, 2, 1, and negative 2, 1. Now as we see, this is not a perfect V. If it were a perfect V, these 3 points here would line up, and they don't quite. So they actually make our U shape, which we've talked about before. And then we can check it using the rate of change. So let's start with our first point. We have negative 1, negative 2, and we have 0, negative 3 as our second point. So remember, in order to find the rate of change, we first need to find our change in our y values. So we see that it is decreasing by 1, and our x values are increasing by 1. So we have negative 1 over 1, which gives us a rate of change of negative 1. So now let's take our second 2 points, and we have 0, negative 3, and 1, negative 2. So to find our rate of change, we start with our change in y, which in this case it is increasing by 1. And our change in x's are also increasing by 1. So we're going to have 1 over 1, which gives us a rate of change of positive 1. Well, as we talked about yesterday, if we have different rates of change, it automatically makes this nonlinear. We can also tell that from the graph, because we can clearly see that this does not form a line, so it's nonlinear. And then the other thing that tells us is that our x is squared in this problem. Okay, if it were linear, we wouldn't have that squared there. We've also talked about when we have x squared, it gives us that U shape. So now let's look at number 3. So we have y equals the absolute value of x minus 2. Now I'm going to have us pick slightly different values this time, and you'll see why, because of the shape. So I actually want us to pick the values 1, 2, and 3. So when we plug it in, we have the absolute value of 1 minus 2. So we know 1 minus 2 is negative 1, and the absolute value of negative 1 is positive 1. Then we have the absolute value of 2 minus 2, which gives us the absolute value of 0. So our answer is 0. And then we plug in 3. We have the absolute value of 3 minus 2, which is an absolute value of 1, which again gives us a positive 1. So if we graph these, we have the point 1, 1. We have 2, 0. And we have 3, 1. Now in order to tell what shape this is, I actually want us to do 2 more points. So if I go 1 to the left, I want us to plug in 0. And 1 to the right, I want us to plug in 4. So if I have the absolute value of 0 minus 2, that's the absolute value of negative 2, which is 2. And then if I plug in 4, we have the absolute value of 4 minus 2, which gives us an answer of 2. So if I were to graph these, I would add these points on here. And we can see that we start having this V shape. So we can go ahead and connect those and draw our V. Now again, we want to check our rates of change. So let's plug in our first point 1, 1 and our second point 2, 0. So we again begin by taking our change in y. So here we are decreasing by 1, so we have negative 1. And then our change in x is increasing by 1, so that's a positive 1 on the bottom. So this gives us a rate of change of negative 1. So now let's look at our second 2 points. We have 2, 0 and 3, 1. So we start with our change in our y's, and our y is increasing by 1, so we put a positive 1. Our x's are increasing by 1 as well, so we have a positive 1 on the bottom, which gives us a rate of change of positive 1. Again, we see that our rate of changes are different. One is negative and one is positive. So since they are different, they are nonlinear. We can also tell from the graph because we clearly do not have a straight line all the way through our graph. And then the other way to tell is this technically is not a regular x since we have absolute value around it. So when we have absolute value, it is always going to be that V shape. Now be sure whenever you do your homework tonight that you make tables for me the same way we made tables for these equations. And then you're going to graph it and then tell me linear or nonlinear. You do not have to check the rate of change on your homework tonight.